90% of the world's supercomputers. They run on Linux.
Yeah.
Just let that sink in. It tells you immediately, this isn't some niche tech. It's absolutely central to, well, the most powerful computing out there.
It really is. A staggering figure.
So welcome, everyone. This is our deep dive made just for you
Yep.
using the Linux material you shared with us.
That's right.
Our goal here, pretty simple. Cut through the complexity, give you the core understanding, the essentials, so you leave feeling informed, not swamped.
Exactly. Get you the good stuff without the fluff.
We've got a mix of things here, some interview questions, general Linux info. So
Well-
yeah, let's dive in and unpack some key Linux concepts.
Sounds good. And that supercomputer stat, it kind of hints at why Linux is so dominant in those really demanding places.
Oh, how so?
Well, it's not just raw power. It's about the flexibility, the customization, and the whole open source community aspect,
Right, the collaborative effort.
Yeah, that lets people fine-tune it perfectly for these massive specific jobs. That adaptability is a massive, massive plus.
Totally makes sense. Okay, so for someone maybe just dipping their toes in, what is Linux fundamentally? We hear the term everywhere.
Okay, basics first. At its absolute core, Linux is an open source operating system kernel.
The kernel, like the engine.
Exactly like the engine. Linus Torvalds created it, released it back in '91, and its job essentially is managing all your computer's hardware resources.
Like CPU, memory, that sort of thing.
Precisely. Processor, memory, storage, and it lists the software you actually use talk to that hardware. It's the middleman.
Okay, central engine. Got it. But then you see Ubuntu, Fedora, CentOS, Debian. What are those? Are they just Linux?
Ah, good question. Those are what we call Linux distributions, or distros for short.
Distros.
Right. See, the kernel itself, the engine, is just one piece. A distro takes that Linux kernel and builds a whole usable operating system around it.
So it adds all the other bits.
Exactly. All the supporting software, libraries, utilities, often a graphical interface, default applications. Think of it like getting the same core engine, but in different car models, different features, different looks, maybe different intended uses.
Okay, yeah. That car analogy clicks. Nice. Now, another term that always pops up nearby is Unix. Is Linux just like modern Unix?
That's a common point of confusion. So Unix is actually a whole family of operating systems dating way back to the 1970s. Really foundational stuff.
Okay.
Now, Linux was definitely inspired by Unix. It shares a lot of the same design philosophy, technical ideas, but Linus Torvalds developed Linux independently from scratch.
Ah, okay. Not directly based on the code then.
Correct. His big goal was to create a Unix-like system, but crucially one that was open source. So while Linux acts a lot like Unix, and you'll hear Unix-like all the time, it's technically distinct. Different history, different development.
Got it. Unix-like, but not Unix. Open source.
Okay.
So thinking about how Linux actually works then, what are the key pieces inside?
Right, the building blocks. The material you shared mentions a few core ones. You've got the bootloader. That's what starts things up.
Kicks off the process.
Yep. And the kernel, our engine we talked about.
Yeah.
After that, something called the init system takes over managing things once the kernel's running.
Init system. Okay.
Then you have daemons. Those are like background services, always running, doing system tasks.
Things you don't necessarily see.
Exactly. And if you're using a graphical interface, like most desktop users, you'll have a graphical server. And the desktop environment itself, like G&A or KDE, maybe you've heard of those.
Yeah, I've seen those names.
And then, of course, all the applications you actually use. Word processors, browsers, games.
That's a good overview of the whole stack, but you keep coming back to the kernel. Why is it the absolute core?
Well, imagine it like the ultimate air traffic controller for your computer's hardware.
Okay.
It sits right between the physical hardware and all the software. It has to make sure every program gets the resources it needs. CPU time, memory access, talking to your printer or your network card.
Without them bumping into each other.
Exactly. Without conflicts, without crashes. It manages everything, enables all communication, that fundamental role. That's why it's the core.
Right, the controller managing resources. So how do we, the users, tell this system what to do? How do we interact?
The classic fundamental way is through the shell, the command line.
Ah, the black screen with blinking text.
That's the one. It's a text-based interface. You type commands, hit enter, the system does its thing.
Seems a bit old school compared to clicking icons.
It might seem that way, yeah. But it's incredibly powerful, very efficient, very direct, especially for system administration tasks. It gives you fine-grained control.
Okay, so typing commands is key. If we're in this text world, where do we start? How do we find our way around?
It all starts with understanding the file system structure. Linux organizes everything, files, directories, in a single hierarchical tree.
A tree structure.
Yep. And the very top, the starting point, is the root directory. It's represented by just a single /fed. Everything else branches off from there.
Okay, is the trunk. What are some of the main branches, the important directories we'd encounter?
There are several key ones right off the root. Bin, that usually holds essential command line tools, the basics.
Binaries, right?
Yep, binaries, etc., think, etc. That's where system-wide configuration files live. Settings for how things work.
Important stuff in there, I bet.
Oh, yeah. Home is where user directories are usually kept. So your personal files, documents, settings would live under home username.
Makes sense.
var is for variable data, things that change a lot, like system logs, temporary files, mail spools.
var for variable. Okay.
And historically, user system resources generally hold applications and files installed by the user or the system that aren't absolutely critical for booting.
Okay, bin, etc., home, var, user. Those give you a basic map. Now let's talk commands. The material mentioned unname asser. What's that one do?
Unname assers. Simple but useful. You type that, press enter.
Yeah.
It just tells you the exact version of the Linux kernel that's currently running on your system.
Okay. Quick check on the engine version. Handy.
Exactly.
Another one was grep. Sounds like grabbing something, searching.
Yeah, got it. grep is your go-to search tool for text. It stands for Global Regular Expression Print, which sounds complicated.
Yeah.
But basically, you give it a pattern, like a word or something more complex, and it scans through files or the output of other commands and shows you every line that matches that pattern.
So finding specific errors in a huge log file.
Perfect example.
Yeah.
It's incredibly powerful for digging through text data, filtering things out. You can sift through megabytes of logs in seconds to find exactly what you need. Essential for troubleshooting.
I can see that being super useful. Okay, what about sudo? That seems to pop up everywhere in tutorials.
That's sudo. Stands for super user do.
Super user, like the admin.
Yeah, exactly. Sudo lets a permitted regular user run a specific command with the privileges of another user, usually the root user, the main administrator.
So it's like borrowing admin powers for just one command.
Precisely. It's a security thing.
Yeah.
Instead of logging in as the all-powerful root user for everything, which is risky, you use sudo for just the tasks that absolutely need those higher privileges.
Wow.
Like saying, okay, system, let me do this one admin thing.
Right. Keeps things safer. Okay. What about checking disk space? How much room do I have left?
For that, you've got two main commands. df is the first one.
Yeah.
Yeah, df for disk-free or disk file system. It gives you an overview of your mounted file systems, basically your drives or partitions. Shows total size, use space, available space. The big picture.
Okay, overall view. What if I want to know how much space a specific folder is using?
Then you use do. Disk usage.
Do.
Do estimates file and directory space usage. So you can point it at a folder, and it'll tell you how much space everything inside it takes up. Useful for hunting down space hogs.
df for the whole drive. Do for specific directories. Got it. And seeing what's actually running, like Task Manager in Windows?
The command for that is ps, process status. Just typing pips usually shows processes you started in your current terminal. But the really common way you'll see it used is po.
Oh.
Yeah, po. That combination of options gives you a much more detailed list of all the processes running on the system, who owns them, how much CPU and memory they're using. It's like looking under the hood.
Okay, PO for the full picture. Now, simple ones maybe. Turning the machine off or restarting it.
Yep, shutdown is the command to bring the system down safely and completely. It usually warns logged-in users, let services stop gracefully.
The proper way to turn it off.
Exactly. And reboot, well, does what it says on the tin. It performs a shutdown and then immediately starts the system back up again.
Simple enough. One last command from the list. Chain. Sounds important. Change mode. Permissions.
Spot on. CHIM is absolutely crucial. It stands for change mode, and it's how you change the access permissions for files and directories.
Who can do what with a file?
Precisely. Linux permissions have 3 levels: who can read, who can write, modify, and who can execute, run a file. And these permissions are set for 3 types of users: the file's owner, the group the file belongs to, and others, everyone else.
Owner, group, others. Read, write, execute.
CHIM mode lets you add or remove those permissions for each category. You can use letters like U+R for user add read or numbers. It's fundamental to controlling access and securing your system.
Okay. Shams or file permissions. Very important. Now, shifting gears slightly. File system concepts. The material mentions soft links and hard links. This sounds a bit more abstract.
It could seem that way at first. Think of them both as pointers or shortcuts to files, but they work differently. Let's start with a hard link.
Okay.
A hard link is essentially another name for the exact same file data on the disk. Imagine two different street signs pointing to the exact same house.
So not a copy, but two names for the same thing.
Exactly. They both point directly to the underlying data blocks.
Mm-hmm.
Because of this direct link to the data on a specific disk partition, you cannot create a hard link across different file systems or drives.
Ah, limitation there.
Right. And if you delete one hard link, the file data still exists as long as the other hard link or the original name points to it.
Okay, direct reference to the data. What about a soft link then?
A soft link or symbolic link is different. It's more like a signpost pointing towards another street address. It doesn't point directly at the house, the data. It points at the name of the file or directory.
So it points to the name, not the data itself.
Correct. And because it's just storing a path name, a soft link can point across different file systems or drives. No problem there.
More flexible in that way.
But here's the catch. If you delete the original file that the soft link was pointing to.
The link breaks.
Exactly. The soft link still exists, but it's now pointing to nothing. It's a broken link, like a sign pointing to a demolished building.
Okay, that distinction is much clearer now. Hard link, same data, another name. Soft link, pointer to a name, can break. Got it.
You got it.
Finally, the big one. The root user. This sounds like the ultimate boss.
That's a good way to put it. The root user, often called the super user, is a special account in Linux. It has absolute, total, unrestricted access to the entire system. Everything. Root can run any command, read or modify or delete any file, change any system configuration, no limits, ultimate power.
Wow. Okay, so that sounds potentially dangerous too.
Extremely. Because root can do anything, a mistake made while logged in as root or running a command as root can have catastrophic consequences.
Yeah.
You could easily wipe out critical system files, break the entire OS.
Yikes.
Yeah. That's why best practice is to avoid logging in directly as root for everyday tasks. That's where sudo comes back in.
Ah, so sudo lets you use root's power for specific things without actually being root all the time.
Exactly. It's a much safer way to handle administrative tasks. Use root privileges only when absolutely necessary and ideally through sudo. With great power comes great responsibility, right?
Definitely applies here. So thinking about that power, any common pitfalls new users should watch out for with root or sudo?
Oh, absolutely. The classic one is the arm-rf command,
Yeah.
trying to remove everything recursively from the root directory. Done as root, that can, erase your entire system.
Okay, note to self, never type that.
Never, always, always double-check commands before hitting enter when using sudo, especially commands involving deletion or failure or changing permissions tab widely. Typos can be disastrous.
Vital advice. Okay, let's wrap this up and summarize. We've covered a lot.
We have indeed.
We started with Linux as that open source kernel, the engine, talked about distributions building on top of it, clarified how it relates to but isn't the same as Unix.
Oh.
We looked at the core components, bootloader, kernel, init, daemons, etc., then dove into the command line, the shell,
The primary interaction point.
and hit essential commands. Checking the kernel version with unname and hour, searching with grep, elevating privileges with sudo, checking disk space with df and do.
Seeing processes with EPS, shutting down, rebooting.
Right, and managing permissions with chmod. Then we tackled those link types, hard versus soft.
Yep, the direct link versus the pointer.
And finally, the all-powerful use with caution root user.
A good tour of the fundamentals.
So connecting this back for you, the listener, hoping to get up to speed quickly, this gives you that solid grounding, the core ideas, the key tools that really drive Linux systems everywhere.
And it ties back to that supercomputer point, this open collaborative model means constant improvement, constant testing by a huge community. That's a powerful driver for innovation, especially in demanding fields.
It really is. Which leads to a final thought to leave you with. Thinking about that 90% plus dominance in supercomputing, what does that suggest about the future? What potential does this whole open source approach hold, not just for computing power, but for innovation in totally different areas? What other fields might be fundamentally reshaped by this kind of collaborative, open development? Something to ponder.
Definitely food for thought.
Indeed. Well, thanks for joining me on this deep dive into the world of Linux.
My pleasure. It was fun.